Okay, so today I'm going to talk a little bit about something called a web application firewall. And the reason I'm talking about this particular thing is because you are going to be, I need to motivate the exercise you're going to do today. And I figured, why don't I just talk about this thing right in place where it's relevant? So what is a web application firewall? Well, it looks something like this. The idea is that you have bad people on the outside, and you have good stuff on the inside. And at the very edge, typically people put some kind of gateway. And the idea of a gateway is, and this is sometimes called a reverse proxy. The idea of a reverse proxy is to pretend to be the server for a little while. You terminate the connection. You figure out what the HTTP request is, and you're like, oh, that request, that doesn't look so good. I'm going to either allow it or deny it. So in this case, it doesn't look good, I'm going to reject it. So, for example, if you have some pesky Portland State computer science students and faculty trying to break your stuff, they're sending XSS attacks and SQL injection attacks. You're going to like, look at that, oh, or 1 is equal to 1. Yeah. Nice try, you're denied. That's the idea of a web application firewall. And typically, you could either put these right near your server, or more often than not, they're actually forward deployed now to be right at the edge of the network. People are pushing this functionality as close to the adversary or the edge as they can. So they are also typically embedded in things called layer 7 load balancers. So if you have a site like google.com, and it's sort of a name that sort of is proxied for a whole bunch of back-end real machines, then you'll often have this L7 load balancer that will not only proxy the request, but figure out which back-end server is best available to serve that request. And so it's often integrated into one product on a cloud service. Okay. So some examples of this. There are a lot of open source ones. Mod security is a common one, where you can just integrate this right into your server. Yes.
What makes a reverse proxy instead of like other kinds of proxies?
Proxies. So one of the things with like burp, like people were using burp. Or actually, you could set up Postman this way. You could say, hey, I have a web browser. I don't want my web browser to talk directly to the internet. I want to proxy all of my client requests to this proxy and then have it access the site. So if you, for example, are Portland State and you're like, I don't want people sourcing SQL injection or XSS attacks, I'm going to proxy every single HTTP request, and then I'm going to stop it right there. So the reverse proxy is typically meant for when the service provider is putting in the proxy. But the functionality is similar, right? I'm going to actually terminate a connection and then pretend to be what you want and then send it over if it's what you want. Now you would do this, Portland State would also do this if it wanted to improve the caching in the network. So if we're all hitting google.com, right now, the only thing that we cache is on the browser, right? Like each one of us will go there, and if the page has changed, we'll download it. But if it hasn't changed, well, we have the copy on our laptop. But Portland State is sitting there paying the network bill, and they're like, God, I have 40,000 copies of google.com's web page being downloaded. Maybe I'll just download one, and then anybody from Portland State who's pointing to the web proxy will just get that cached copy for the organization. It's very similar to, I didn't talk about DNS in this class, but DNS caching, where it's like, I don't have to look up google.com for every single person in Portland State. I would just have you point to a local DNS server and have that thing proxy the DNS requests so that only one lookup in the morning by the first person who's on Google in Portland State is the only one that actually has to look up google.com. Yeah. It's still there cached? Oh yeah, yeah, that's Yeah, we'll talk about that. Yeah, the caching has been abused left, right, and center. We're not really talking about it in this class, actually. But yes, caching attacks, for sure, have been used against legitimate providers for benefit. So here are some example of in fact, this might be a couple years old, but like these open source versions of this are quite prevalent. There's a huge industry for commercial versions of this. So I was walking through the Portland airport one, I think this is like last year. In fact, that ad still might be there. You know it's a big industry if you walk through an airport and see a Barracuda ad advertising their WAF. So a lot of people have, a small number of people have made a lot of money doing commercial versions of this idea. So AWS has their own WAF sort of implementation that you can actually use. Cloudflare is another one. Cloudflare not only does the WAF for exploitation, to protect against exploitation, but if you take the cloud class, I show how this is being used to prevent denial of service attacks, right? If I can proxy the connection at the edge, I can drop that traffic. If that's the person sourcing 10,000 requests per second at me, I can actually drop that traffic further up. So yeah, these are some of the commercial products that you'll come across. But this is one of those cases when the solution is part of the problem. And you have this all the time in security. Someone deploys a security solution, and it actually created the problem. One of the most famous examples of this are the antivirus software that people are running. Those things can be horribly insecure, and by installing that thing, you're actually exposing yourself to even more vulnerabilities. So in this particular case, this was one of the cases where actually having this prevention measure made the entire organization more vulnerable. So this is a picture of the Capital One breach from last summer. And this is what you'll be doing in class today. You'll be sort of replaying the steps of this. The adversary is sitting here behind this anonymizing network. So Tor makes it so that you can hide yourself, the true origin of a request from the destination. And we covered SSRF. The adversary launched an SSRF attack against the AWS WAF. So there's a web application firewall there. Capital One deployed it, thinking that it would stop all of the bad stuff. And lo and behold, this WAF was used to point to the metadata server. So this is the thing that we covered last class. And this metadata server had a bunch of credentials. It had a set of credentials. The adversary pulls these credentials off of this metadata server and then uses the credential to then, from the CLI, go and leverage the credential to dump the credentials of all of the S3 buckets that that particular WAF had access to. Okay, so this is the exploitation. Okay, so there are two issues with how Capital One deployed this WAF. The first one was a misconfigured WAF. So here you have the WAF in the center. The WAF was allowing URLs that were pointing to the internal metadata service. Those should have been explicitly disallowed. So that was number one. They should have been dropped. The other one was once the adversary was able to get to the metadata service, the credentials that were pulled out of the metadata service, they were over-provisioned. They were allowed, and I don't know why you want a WAF to look at any of your storage buckets, but this thing was allowed to have access to all the storage buckets in the back end for Capital One. So so two things combined made this thing, made the solution worse than the initial problem. Okay, so one of the things that you'll be doing in the Flaws 2 Defender path, if you've actually already gone through there, one of the things that you do is play a game of one of these things doesn't look like the others. Because you'll be going through there and you'll be like, oh, here's an access using this credential. It's done from this. So CloudTrail, you'll be looking at a bunch of logs log entries, and you'll be like, oh, there's one. Somebody's using this credential from the AWS CLI. And you're like, that's probably not a good, like the WAF credential is being used as within a CLI. That should not be the case. So this is where one of the proposed solutions to this was to use a Lambda function. So this is some kind of trigger that when you get an anomalous event in the CloudTrail, to use that event, the credential being used in the CLI, to then detach the role and invalidate the credentials. So I wanted to put this up there because I'd like for you to see a remediation that is using sort of the cloud services to turn around and protect itself from compromise. Okay. So with that, we are going to go straight into the lab. I want you to finish this lab today, and then, well, hopefully by the end of the day, hopefully by the end of this class. It's not going to take that long. In fact, yeah, an hour and a half, I'm pretty sure everybody can get through this lab in an hour and a half. If not, I'm doing something wrong. It's on me if you can't get it done. So we're going to do Cloud Breach S3. And I'm going to show you, just walk through exactly what you're doing. It's very short. So this is what it looks like. At the beginning, when you click that link, you'll get an IP address. And that's the IP address of the misconfigured proxy. And then what you're going to do, you're going to hit that IP address, and it's going to be like, hey, you need a URL in order to use this service, because it's a proxy, so you can't just access it without a URL. It's going to say, no, I need one. I'm going to proxy it for you. And then what you're going to do is you're going to attach a URL to it that basically tries to hit the metadata service, which is this one in the middle. And then you're going to use the CLI to assume the role of whatever role was attached to the credentials that you exposed as part of the metadata service. And then you're going to use that to list all of the S3 buckets. And there was a stray bucket earlier this morning, or from last night and this morning, that I have deleted. So there's only one obvious bucket to hit. So you're going to list it. It's going to be obvious which one you're going after. It's like got credit card numbers on it or something like that. And then you're going to sync the entire bucket over and then spit out the contents. Okay, so that's what your lab is today. So this is the first part, the first 3 steps. You're just curling against the proxy, that the IP address to get the credentials. And then as soon as you have the credentials, the next step is to just enter the credentials into using AWS configure. The profile you're going to create is called erratic, because the woman who did the exploit, the way they caught her was that she was basically bragging about it on some channel and used the erratic handle. So you can actually read about a little bit more of the history of this if you click on that article. And then you'll be taking on the erratic profile and then syncing the bucket over the contents of that bucket. Okay, so this is what's getting Amazon in a whole heap of trouble, right? That it should never be this easy to break into someone's stuff in the cloud. So the fact that this metadata service is exposed is something that finally, AWS is finally taking some steps to make this not possible. Google has already taken some steps, but now Amazon is definitely shutting this vector down. Okay, any questions before I let you just get started? Yeah. Step 7. Wait, where's step 7? Oh, yeah, no, we're doing these one at a time.
Oh, okay.
Yeah, so you can't do we'll do this one on Tuesday. It's very similar, but there's some other steps. Yeah, so if you've already done step 6, well then, yeah. I've only been releasing these one at a time, just because if you go in there and you try and list all the resources with all the levels running, you'll get overwhelmed. So, okay, so that's all I'm going to talk about today. I'll just let you finish the lab, and then hopefully by the end of this class, if you still need more time, let me know and I'll delay it. Otherwise, I'll launch the next one for you to get started on.
Some bad news. I just wrecked the EC2 SSR. and I don't know how to recover from it. This just happened. I was trying to restart it because the web server apparently crashed, and then in trying to restart it, Terraform hung. Now I don't know how to recover, at least not in 5 minutes. I couldn't figure it out, so I guess we'll be sitting around looking at each other for quite a long time here. So after I'm done talking about these levels, I'm going to try like crazy to bring the level back up. It's not a long level, but I might have to delay. I might have to do EC2 SSRF Thursday and then just open up the last level after. So I wanted to give a little bit of both of these show you how an adversary, when they get a foothold into some resource in your project, how they would laterally move around it, try and get what they're after. So the first one was EC2 SSRF, and you start out with this credential that is bound to the access that you allow on this role is lambda. So you can see lambda and then try and execute that lambda. It needs authentication. You don't have the access to that role to execute that lambda, so that should fail. That shouldn't stop you because when you do the list, part of the describing the lambda's environment variables are associated when you do when you describe on the lambda. All the environment variables is a problem because the thing that's sent in environment variables is of the lambda. Just by looking at the metadata of the lambda function, you pull out a different set of access. And these are keys the lambda is using to authenticate its access to the rest of the platform. So when you expose that, you have another set of credentials, and they have you instantiate that as W. So this is the lambda's role when it's being used to access the resources. From this set of credentials, you can basically do a listing. So you can look around, see what buckets it has, see what instances it has. One of the things it has listing access to EC2. So figure out what all the instances are that are running on this EC2, and you find that proxy, which apparently wasn't working this morning. It definitely doesn't work now. That. And then from this, is the cloud breach level. So once you're on this, once you list the proxy, actually exploit the proxy with the metadata service, just like in cloud breach. And this will give you the AWS credentials of the proxy, right? Because the proxy has a different role than the Lambda does for it to access all the different. We'll call this these credentials. So the oval means different roles in the cloud project. Distinct roles in the cloud project have different levels of access. So create another profile in your AWS credentials called the EC2 role, and then you're going to take on these credentials. Look at what else this thing has. And one of the things that it has is a listing permission bucket. And then from this S3 bucket, you can see that there are more credentials in the file. You can get another separate credentials. This is the thing that then allows you to This is something unlike anything you'll see in standard Unix environment, right? Like this kind of role-based access control is done in the cloud. This is something, this is a different model of security, right? We used to just teach you securing a machine, Unix accounts and firewalls. This is a brand new ballgame. Securing all of these things. Okay, are there questions about that? It's an awesome exercise if it works. Not so awesome if it doesn't work at all. Okay, so after that one, the last level I was going to have you do was this remote code execution web app. And it's going to do a similar thing. So the previous level was all done with IAM roles. This is going to be done with more legacy methods. So we talked about there being multiple ways of operating in the cloud. This one is using legacy kinds of things to do something similar. So you're going to start out again with some credentials. The profile that you create, you list some buckets. You find in the S3 bucket a bunch of log files. The log file is innocuous, it's just got logging information, but what that does is in the log file, it reveals a URL to a special path in some website project. So that you'll get this URL in the log files, and it will point to some ELB. So ELB is an elastic load balance. Has one IP address, maybe half dozen, but there's more than a half dozen servers from that name. And this load balancer is a networking device that acts as a reverse proxy that takes all the incoming connections heading for Google.com and then just sprays them all to the backend server that actually process requests. So you'll have a load balancing front end that will route the request to the backend. You find that these ELB logs are there, and then you can pull out this admin URL from the log files. And then as part of this hidden admin UI interface, so you see that you find the route, you basically see that this admin site, it's like Webmin, where it allows you a web interface to execute commands UI for systems, except to allow any random attacker access to that UI. They've got full-on access to the servers. So in this case, you have this web form that you come across. It will just accept arbitrary commands. So what you'll do is you'll generate your own SSH, and then you'll take the public key that is part of that private key there, and you'll append it to the SSH file of the root account on that instance that you're trying to attack. That's basically what this UI allows you to do. You can append to the root account the key and then get access to this EC2 instance that is serving this site. And moreover, the role associated with that, like in the previous one. So there are two ways to solve this level. One of the things you could do is this EC2 instance connects to a backend database. One of the things that happens when you instantiate an EC2 that needs to connect to a backend database, typically configure the EC2 with a startup script. And that startup script has like the database parameter. This is the IP address of the database, the username, this is the password, the table. Set up the database connector. That's all stored in the metadata of that EC2 instance. So if you're on that EC2 instance, you need those credentials, you ask the metadata. What was the startup script that was used to launch the instance? And then that's got all the credentials inside. So that's one way to solve the level. The other way to solve this level So you're not going to do that way. You're going to do a different way. There's a way of solving this level where you has the ability to access storage buckets. So you can instantiate, I think the very first person who gets at this level can install the AWS CLI. From there, you can use AWS CLI to storage buckets. And you can also, so what you do is you the same one in a file. The other thing you can use the CLI for is to access to a backup database. Well, which ones are they? AWS, RDS, list instances, and then you can find the IP address of the RDS database using the CLI. And then because you know location of the database and you got the credentials from this file, you can then just use standard command line access the database and all the information. So you can see this is more like kind of compromise. So those were the final two things. Questions? So if you can work on other AWS stuff, I'll try and get my act together here. If not, I might just bring up RCE web app and then just fill EC2 in. All right.
Okay, so you come over here to this thing, and then you see there's the credentials that you start with. So those are the new credentials. And I have you configure this as Solus. So I will you can either do the actually, you know what? I'll do it the way all of you are doing it, probably. So paste that in, and I'll paste this in. US East 1, and then so now I have the Solus, and no, I don't want to do that. I want to list the lambdas. So that's the command. AWS lambda list functions -- profile Solus. That's the first step of this. If you, well, let me go to the next one. So after I do the configure, this is the next thing that I'll execute just to see what Solus has access to. I'm going to pipe this into less. Whoops. So I can scroll around. Unfortunately, this is co-located with the serverless goat lambda. So the very first lambda is from that thing that the 4.2 that you've been doing, so ignore that. If you scroll down, yeah, this is you see this is CloudGoat. So CG lambda is the CloudGoat. And you scroll down here, and then you see the EC2 access key ID and the EC2 secret key ID. So, so these are keys that you can then configure as a new, well, so one of the things I have you do is try and invoke this thing. So if you do this, you'll see that this gets refused, like because you don't have the execute permissions. I'm going to skip that part, but you basically from this, if you see the function name that's being called, and if you go into the list, you can see if you actually tried to do an invoke with that as the function name, it'll fail. So you don't have execute permissions. And so with this, with these credentials, you can then configure another profile. So I'm going to copy that. I'm in a TMUC session, which I would recommend you do if you AWS, so you can have multiple shells. So I'm going to configure a new profile called WREX. And then I will paste that key that I just found. And then I will paste the secret key. US East 1. So now I have this new profile, WREX, that I can then use to list the EC2 instances. So that's the next step of this level. So I will do that now that I've configured it. So AWS EC2, just so I've done this before, so it remembers that I've done this before. AWS EC2 describe instances using this profile WREX. And you can see, so I've got some of these from a while ago, so not all of these are. If you search for CG, you'll see the, here's an instance that's got some CloudGoat EC2 pair there. Oh, that one's terminated, sorry. So this is from a previous deployment. Unfortunately, this is why I'm trying to do this one at a time. Because if I had all of these up, you'd be sifting through a ton of stuff. But this is how AWS spits its stuff out. Unfortunately, these are old. So here is the one that is actually alive. And you can see, you know it's alive because it's got a public IP address. So this is the IP address that you can then pull out. And so I'll pull this out, copy that, and then I'll try and go to it. And it gives me this error. So this node server wasn't up before, but now when you get that IP address, you see that this is some error, and it says URL must be a string. And what this is looking for is some parameter, is basically a URL parameter. And so this is a needle. So Node has this needle package, and the needle is asking for a URL. It's basically a proxy. So what the CloudGoat thing has you do is to then say, oh, you know, supply it with a URL parameter. So we will access it with a URL parameter. How do I have that? Question mark URL. And then this is basically an SSRF demo. So we all know what to do with an SSRF. We say URL is equal to http://169.254.169.254. And then it gives us this, and they're like, okay, well, how about latest? It gives us that, and then so on. So you can go for the win on, you can get the credentials for the EC2 role that's being used to run this proxy, is the next step. So let's go back here. It's the next part of this. We're just going to go all the way down. Just copy and paste this. Security credentials. That's what I'm going to paste here. And then you can see this is the role that this EC2 instance is using to access resources on this cloud project. So if I copy that, paste it onto here, then I will get a access key ID, secret access key, and an access token. So this is the last step of it. So now I can take on this this role. you have a question, or are you stretching back there? Stretching? All right. So then what I'll do is I'll configure another. This is the EC2 role that I've just scored from the metadata server. I'm going to configure that. So there's no way to enter in the token through AWS configure. So what I'll do is I'll first do an AWS configure, -- profile, EC2 role, the access key ID is this thing. Secret access key is this thing. US East 1. And then what I will do is I will manually stick in the token. Hopefully it doesn't expire on me while I'm doing this. AWS session token equals. And then I now have this session token, which is going to go run off the page. But I have to hustle, otherwise I'll have to do this over again. I have to get rid of the quotes and the comma. Okay, so then this thing asks me to use those credentials that I just entered in to just do an LS. So to see what buckets it has access to. So AWS S3 LS -- profile EC2 role. And you can see all of these buckets. And so I have a bucket here from a previous instance. I have to manually delete that. But this is actually the bucket you want. It's associated with the role that you just got. So then I will do a list of that. So this is the bucket I'm trying to list. This just got, you can tell by the timestamp it got created. This one just got created. That one's from the broken version. So then I will do, on that profile, I will try and list the bucket's contents. And then there's this admin user, so then I will copy admin user.txt into my own current directory. And you can see, oh, there's another credential. So there's, I don't think that was in the slide. I think I skipped a step in the slides. But then that's another credential you can use. So that's step 4. So this is the last, oh no, I did have this. So then I'll configure this credential. So AWS configure -- profile, and then this one is shepherd. And then this is the access key ID. Oops. And this is the session. US East 1. Okay, so now I have the shepherd, and then I can actually invoke that function. And of course, I'm going to need the actual function name. So, all right. Copy that function name here. This is the function name. All right. AWS lambda invoke -- function. name. Then I'll paste the function name without the without the colon in there. ./out.text profile shepherd. And I got a 200 saying, yay, you invoked it. So that, when you did that the first time as Solus, it would have given you a, I don't know, a 4.0 something. So now you got it, and then that's the file. You win. Okay. So, if I could have you do that, yeah, I'm going to leave this level up for at least a day. So if you can walk through that, that would be great. And I will be encoding this and uploading it soon, so that you can actually just do a video walkthrough of what I just did. All right, any questions? Yeah. Yeah, till tomorrow at least, maybe longer. Actually, I'll leave it all the way up until the beginning of next class, because I'll just switch it over to RCE. Because I already went through the RCE by next class, and I'll just switch it over so I can start the tools section on Thursday. Yeah. Yeah, so by beginning of class on Thursday, you'll be able to do this level. Okay. And let me know if that web server crashes. This is other people's code, so if I don't know what, like, how robust it is. Clearly it's not as robust as I thought it was, but yeah, I'll monitor that. I'll monitor the Slack channel. All right.